not deserving premium when they can't even shuffle with us. I didn't even hear no more girl by SZA this morning. Did they
Introducing the YouTube Black Voices Creator Class of 2021. We always talk about, man, we got our 4 black stuff. We want to introduce black creators to you. Anybody need calculator wipe? They use your calculator today?
I'll use this one. Okay.
Yep, no. Guys, do me a favor, turn the desk face that way. There, you don't gotta drink yours. Nobody sits there. I don't let them. See you guys. Have a good day. Well, yeah. Have a good night, man. Regan, come take a look at that task.
I can't. I don't know. I can get it to work. So I had to do it on my phone. I know it's supposed to do it. What'd you say?
Yeah, I don't understand points and flush.
Yeah, I watched Khan Academy on it, but I don't know if that's even something to do.
I watched the Khan Academy on the second one that was on the quiz. Because I didn't know what that meant, but it was just a
It's
strange
just,
thing.
it's mean value theory.
I didn't know that. I wasn't there for that whole lesson.
I just looked it up and it said, yes, you were, Kelly, you did in class.
Miss Bob, please come from house.
Bounty animals increase decrease contact.
No.
I have a question. Do you think you could like go over second derivative a little bit more?
That's why we said on
Yeah.
live stream that we're just going to redo that today. We're gonna finish up our lesson today.
Okay.
Well, you were there. I know you can't attend on Tuesdays.
I was there for a little bit.
You were?
Yeah.
I think, I don't recall, I don't know if I saw you or not.
I put I'm here, but I was only there for a little bit. Bianca.
I know you were.
Miss Leatherwood need you to, hold on.
Yeah, some of you guys need to register for AP Calc test, by the way.
Yeah, Bianca, you're gonna edit how you have
It's my
to,
apes, isn't it?
and I've got your code,
Awesome.
and then Colin and Fatima, y'all have to do AP Calc, and I have the code for that.
Actually, let me just take a picture of this so y'all can take it.
How'd that Unit 2 test go, by the way? Wasn't that fun? Now that I have it graded and put in?
Surprised at how I did. I thought I was gonna do a lot worse.
Yeah, there's only two categories, people who did well and people who didn't do well. There is no in
I
between.
did better than I thought I was going to.
Well, that's also a great category. Better than I thought I would is also a good category. Not as good as I thought you should have.
No, not as good as I thought I should have
Because
either.
while I thought Unit 2 is a little tough, there's nothing on that test that was not fair. Everything on the test was something that was discussed in class. There wasn't anything new, wasn't any challenge, problems, if you will. Though we do need to talk, because I believe I talked to about this on live stream on Monday or Tuesday, but we'll talk again today in person live about the little too much help going on. And unless we want this to end up like AP Stats, I suggest we modify it. Where is everybody else?
Good question.
Yes, 76.
Well, I've spent like a good 3 hours on it, and I got to the point where I was like, okay, I know how to do
I
these
think I got,
9.
actually, I think I had like a 70 on, I got some more points because or something, because I like added up the ones that you took off and it wasn't 76.
Yeah.
Well, I was just like, okay, I tried really hard on all of them, and then the ones I knew how to do, I did them and didn't worry about them, and then the ones I didn't know how to do, I spent all the time. I think I did them.
Sometimes the ones I don't know how to do, if I can.
Let's get started with our warm-up problem, please.
Overthink it and it's like nothing.
Let's get started with our warm-up problem, please.
I think I can make a lot of.
We have no homework to check today. As I told you before on live stream, if we didn't finish our lesson on 3.4, I'm not coming around to check 3.4's homework, because you don't know how to do yet. Or if you do,
What about 3.3?
oh yeah, I guess I have to check your guys' 3.3. My bad. Scott, I'm getting ahead of himself.
I mean, you don't have to if you don't want to.
I mean, you want the points, don't you?
No,
Yes.
definitely.
We're missing
Which
Jake, we're missing Abby, we're missing.
Oh, it's 3.1.
Have you already checked 3.1? I can't
Yes.
even remember.
Yeah.
We did 3.1 and 3.2 together. Here,
Oh, yeah.
you guys were the first group that did the live streaming for 3.1 and 3.2. The only homework I should need to see for you guys is 3.3.
That should be all 3.
No, I need to see your guys' 3-2 as well. Yeah.
First half.
Let's take about 5 minutes. Let's work on this warm-up problem. Need an answer more than that. Actually, you know what? Let's do it together. Let's do it together. Since we don't have homework questions to work over today, let's do this together. Then we'll go ahead and get our proverbial show on the road here. Okay? So, I want to find the intervals of increase, decrease. I want concavity, and I want the max and mins here for this question. In other words, I want you to do what? Look, there's 4 of you here today. You're all going to have to talk. Missing almost half your section today. So, what we got to do? Find these things. What have I asked you to do?
Do the first derivative test and the second.
I want us to do first derivative test and second derivative test. That should give us, first derivative give us increase, decrease, max, mins, or at least give us an idea of that. Concavity should help back that up. So, let's start with the first derivative, of course. F prime of x, 4x cubed minus 9x to the second plus 2x. Okay, if I want to run the first derivative test here, we're going to go ahead and set this equal to 0 and solve. There's no point here where this does not exist, so I don't need to worry about f being does not exist here, right? This is a continuous function everywhere. So, first thing we're going to do is we're going to factor out a GCF. 4x squared minus 9x and plus 2. Okay, and then we can try and see if this factors. We can try and see if this factors. If it would factor, I'm thinking that it might factor into 4x minus 1 and x minus 2. Mr. Cochran got lucky with his design and actually wrote something that would factor here. That was unintentional as I made this problem up on the spot, so we kind of got lucky. Questions here, concerns here about this one thus far? So this gives us 3 critical values that we're going to look at. We have x equals 0 for our first term. We have x equal to 1/4 for our second, and x equal 2 here for our last. So as we continue to work the first derivative test, we have 0, 1/4, and 2. So, what do we need to do now? What do we need to do now?
Plug in values that are on either side of those.
Okay, where are we plugging in those values, Bianca? Into our first derivative or back to the original?
The first derivative.
The first derivative, okay? So what number should we pick for less than 0?
-1.
I think negative 1 makes a really good argument here. So if I plug that in, I'm going to get negative 4. I'm going to get minus 9 and minus 2. Everything there is negative. So we're looking negative right here. Between 0 and 1/4, what should we try to plug in? 1/8. 1/8 sounds fine. Put in 1/8. So when I plug in 1/8, might want to do this work over here. 4 to the 1/8 cubed minus 9 to the 1/8 squared plus 2 to the 1/8. Okay, this is going to give you. You could also use decimals here, by the way, for this one. This might be one of those times where I would encourage you to use decimals. What are we going to get here?
I got 0.117.
0.117. Positive 0.117. It should be positive here. So plus. Okay, what are we going to put in between 1/4 and 2? 1 makes the most sense, doesn't it? If I put in 1, I'm going to get 4 minus 9 and plus 2, and that is also still negative. And then anything above 2, we could say, I don't know, 3. So that would be 4, 3 to the 3rd power minus 9, 3 squared, plus 2 times 3. So this is going to give us 27 times 4, which is 208. No, 108. Excuse me, 108. We're going to get minus 81 and plus 6, and this looks like it is positive. Questions here. So first derivative test here in red is what we've done. Now this will help us acquire the intervals of increase and decrease, and it can also help us do max and mins here. Can also help us do max and mins here. So let's go ahead. Let's write this out here. So what do we have here for increasing, decreasing, max, min? What do we got?
It's increasing between 0 and 1/4.
Okay.
And between 2 and infinite. Positive.
So something that I pick up on right here, Bianca's telling me, is because this is increasing 2 through infinite, right? Because it's increasing through there, it never stops increasing, meaning there should be no absolute maximum, right? Okay, what about decreasing?
Negative infinite to 0. And then 1/4 to 2.
So once again, because this is going on forever decreasing, I should have no absolute minimum. That's something that we can interpret out of our increasing and decreasing. It's not explicitly stated. I haven't explicitly told you that until now. But if you apply a little common sense, a little thinking to it, if I'm increasing forever, how could I ever have a maximum? If I'm decreasing forever, how could I ever have an absolute minimum, right? So that means that these will be relative. These will be relative. Now, of course, if we cut that off, we trim this down to only a specific interval, say between like -3 and +3. Now, because we're not going on and on and on forever, now we would possibly have an absolute max or an absolute min, right? Okay, what are these? First, let's start with where are they, and then we'll talk about what are they. Where are they taking place? Where's the maximum going to happen? Not at 1/4. Wait, no, yes, at 1/4. Maximum, I said first. So this is happening at 1/4, right? And that means, where's our minimums happening? 0 and 2. Okay, now these are all where, so let's go ahead, let's get in this practice right now. We need to list out both here x and y for these. We list out both x and y for these. Where am I going to get the y value from?
the original.
I gotta go back to the original equation to get the y value. So back to here to get these. Well, one of these is real easy, 0, 0, right? 2 shouldn't be that bad either. 2 to the 4th is 16. 2 to the 4th is 16. Minus this would be 24 plus another 4. So I'm looking at a negative 4 here for that one. A relative made at 2, negative 4. 1/4 is the only one that's going to be really challenging up here. And that's going to be, this is 1 over 256. This is going to be minus 3 over 64. And plus 1/16. So that's what makes this a little bit challenging, is of course that they're all fraction. Of course you could go decimal version if you'd like. Did anybody do the decimal version real quick?
Yeah, I got 0.019.
0.019. Okay, as fractions here, this would be, if I want to switch this over, this be, or actually right over here, 1 over 256 minus 6 over 256 plus 16 over 256. We want to do it that way. 6. And all of that, of course, is going to come together to be 9 over 256. 9 256.
My calculator is 5 over 256.
5 over 256. Let me Mr. Kaufman double check his math here. Multiply by 2, negative 6. Multiply by 16. 17 minus 6. No, I'm still getting 9.
Because I found the decimal and then I went straight to fractions from it and it's 5 over 256.
You said 5?
Mm-hmm.
Let me see what you plugged in there. Well, maybe Mr. Kaufman's making a mistake on the board. This looks like it's right here. I'm probably making a mistake on the board. Either way, we should get the y values, then we know how to get the y values. So that takes care of these questions: increase, decrease, max, and min. So let's talk about concavity. So that was truly the part of the warm-up that I wanted to do. Let's go ahead. Oops, I probably shouldn't have erased that, but that's okay. Let's run our second derivative test. That's going to tell us our concavity. So first we need to get our first derivative back up here, because I accidentally erased it just now. 4x to the third minus 9x squared plus 2x. Okay, so that's the first step, of course. Now we're going to run the second derivative test. We need the second derivative. This is going to be 12x squared minus 18x and plus 2. Correct? Okay, now we need to go about this the same way we did the previous one. We need to find where it's going to be 0. We need to find where it's not existent, right? There's not going to be any point where this does not exist. There's no vertical asymptotes, no point of discontinuity, because we have a standard quadratic graph right here, correct? So we should try to set it equal to 0 and solve it down. So f, second derivative of f equal to 0, 12x squared minus 18x and plus 2. Well, I see a GCF in there, so let's take that out first and let's see what happens after. And yeah, I don't see anything else that's going to help me here. This ain't going to be factorable this time. Mr. Kaufman ain't that lucky. Ain't that lucky. So if it's not factorable, where are we going? Our good old friendly quadratic formula. So let's go ahead, let's set that up. We're going to have 9 plus minus. It is a positive 9 because our 9 is already negative. Our b is already negative. Negative 9 squared minus 4 times 6 times 1. All over 2 times a, 2 times 6. Let's go ahead, let's do the reducing here, plus minus. This is going to be 81 minus 24, all over 12. 81 minus 24, let's see here. I believe that should be 57, is it? Good. Okay, so that gives us, of course, 9 plus minus the square root of 57 all over 12. All over 12. Any questions here or concerns here so far? Now 57 is not going to break up, as I've taught you in Math 2 and as I'm currently reteaching them in Math 2. So we would leave it like this. Of course, we need our positive and negative roots, right? But we don't really need to stress that too much. We just kind of need a ballpark of where this number is going to be at, don't we? So what I would do here is I would just do this one time. Well, I guess we're going to have to do it twice. Let's go ahead, let's do it twice. Let's get a decimal here for each of these. Let's get a decimal here for each of these. Let me grab a calculator where. Let's get this one right here. So, let's go 9. Let's go plus route first. Divided by 12. That gives me roughly 1.38. Let's go our minus route second. So 9 minus the square root of 57 divided by 12. And that gives me 0.128 or 0.12. It doesn't matter specifically what these values are because these are our inflection points, right? We already have them as exact right here if we really want them to be exact. But really we're just trying to test above and below them, correct? So while I didn't pick a super nice one, you can pick easy numbers to go in between here, right? Of course, on this side, we should plug in 0, right? What's going to happen if I plug in a 0?
2.
I'll get back 2 because this will be 12. 0 squared minus 18 times 0 plus 2, so that's positive. If I put something in between here, how about 1, right? This would be 12, 1 minus 18 times 1. Plus 2, this is going to be 12 minus 18 plus 2, that's negative, right? And then, of course, on the other side, we could put in 2, so this would be 12, 2 squared, minus 18 times 2 plus 2, this is going to be 48 minus 36 plus 2, which is positive. Questions here about what about this? Okay. So what does this tell me now for concavity? We should be able to say CCU, CCD, concave up, concave down. Where are we concave up? Somebody other than Bianca, please. So let's just use this here. Negative infinite to our 9 plus, oh, that one would be minus square root 57 over 12, right? Where we concave down, in between the two roots, right? So that'd be 9 minus square root 57 over 12 and 9 plus square root 57 over 12. And then we'll be concave up on the other side of that as well. The 9 plus square root 57 over 12 to infinite. Questions here? Concerns here? So just like I showed you that you can read the increasing and decrease to tell you whether or not you'll have an absolute max or min, you could actually do the same thing here with concavity too. Because this is concave up forever and concave up forever, I know that I will not have an absolute max because I'm going up and up and up forever, right? So I'll have one section where I'm concave down, and that's a closed interval between them. So that means that concave down, I will only have a maximum. When I look at this, concave down means max, concave up means min, right? That means I should actually have an absolute in this function. I should actually have, or no, excuse me. It means that I could have the possibility of it. That's where we refer back to the first derivative test to talk about whether or not it is or is not absolute. Okay? So it kind of helps give us a peek into that. It won't really I guess I misspoke. It's not going to tell us whether we have absolute. It'll tell us whether or not there's a possibility of. Does that make sense? Okay. So that wraps up what we talked about on Tuesday. So, as I said on the board here, I want us to start with number 12. Or not number 12, slide 12. And I'd like us to go ahead and try slide 12 out. I want us to find the points of inflection and discuss concavity. So looking at this problem in particular, example number 4 on slide number 12, I'd like us to go ahead and get started with this one, the x plus 2 cosine of x. That's what I'd like us to work on here. And for this one here, we are only doing concavity. Go ahead and tackle this one. See what we can do here.